Example number 4. Draw the projections of a cylinder of 30 mm diameter and 65 mm long, lying on the ground with its axis inclined at 30 degree to VP and parallel to the HP. Here the dimensions are 30 mm base and axis height as 65 mm. But here the most important thing to note here is the instruction here, lying on the ground. This is very important. Now the cylinder is lying on the ground. That means it is not perpendicular to HP. It is lying. Its axis is inclined at 30 degree to the VP and parallel to HP. This means there will be an inclination with respect to the vertical plane and it will be parallel to the horizontal plane. Anyhow, it is lying on the HP. That itself means it will be going to be parallel to the horizontal plane. So we will see first how to imagine this. Now on your screen, the cylinder is directly standing on the horizontal plane. That means it is perpendicular to the HP. But here in this question, it is mentioned that the cylinder is lying on the ground. So I have to make the cylinder lie on the horizontal plane. That means lie on the ground. So I will make it. So here you can see that. Now I will just bring it in the center of the horizontal plane. So now you see that cylinder is directly lying on the horizontal plane. So when you see from the front, you will find one rectangle here. From the top also there will be a rectangle, as you can see here. But here in this question, it is being inclined to vertical plane. That is why I'm rotating here. So I'm now making the angle with respect to vertical plane and the axis is remaining parallel to the horizontal plane. No matter how much I rotate this, it is only rotating with respect to the vertical plane and the axis is parallel to horizontal plane. So this will be your final top view and this is going to be your final front view. As you can see here, if I will erase the planes, so only this, if we see only cylinder, the front view will look something like this and there will be ellipse at the two corners. So when you draw this in the drawing sheet, it will look something like this. So you can see, and the left hand side ellipse will come in the some dotted lines, and this will be your final top view. So front view, top view. So we will see now how to draw this.
As the inclination is given to the vertical plane, first we have to assume that the cylinder is resting on the ground with its axis perpendicular to VP, which will mean that, yes, again I am taking this with 2H pencil because this is not part of our solution, but this is required for our solution. Circle of 30 mm. With 2H pencil. As it is mentioned that it is lying on the ground, this will mean that my XY line should touch this circle here. So afterwards these projection lines and also the axis line. The rectangular portion of 65 mm height is completed, but with 2H pencil because this is not part of our actual answer. So as the angle of inclination is given as 30 degree, I am taking this angle 30 degree now, and I will draw the axis line first here. This will be enough. And I will align the drafter with this axis, inclined axis line, and 30 mm. Remember that this portion is 15 mm and this portion is 15 mm. In total, this will become 30 mm. As you know, the height is 65 mm. This completes our front view. For getting the top view, I will project these same lines from the front view. Sorry, the top view. As mentioned in the earlier question, I have told you that this circle can be also be divided into 8 or 12 number of parts. This circle can be divided into 8 or 12 number of parts in order to get the ellipse. So now I will draw this circle into 8 number of equal parts. So this total angle is 360 degree. We need to divide in 8 parts. 360 by 8 will be 45 degrees. As this is 45 degree, now again I am measuring this with the protractor scale 10, 20, 30, 40, 45. Again 45. If you don't understand this, just think that this is a pizza and you are 8 friends and each friend wants one piece. So these are 8 pieces of a pizza. 8 equal shares. And I have to mention some numberings here. 1, 2, 3, 4, 5, 6, 7, 8. And I'm projecting lines from there. See that if this is 1, this will become 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash. 2 and 8 will come on the same line, 3 and 7, and 4 and 6. And we have to take these lines in this our main front view, main top view also. For that reason, we just need to either we can measure the distance or we can directly just measure this length with the compass, and we can point out here, so that we can take these lines easily afterwards. And now I can mention here points 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, then 6 dash, 7 dash, 8 dash here at this point. I will project these points from the front view also. So now it will become very simple. Just see that how I will match the points to get the ellipse shapes. Here this is number 1. Here this is 1 dash. So let's see that 1 dash and 1. They will meet here. So I will direct at this point. Here this is 2 dash. Here this is numerical 2. I haven't projected from here. This point and also this point. So this is 2 and this is 2 line. They will meet here. Likewise, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8. We will get this portion here. And the same way, if I mention 1 dash here, this 1 will come from this side. So this will be your point. So this 2. Again I have points. So this line number 2 and this is line number 2. 3, 3, 4, 4, 5, 5, 6, 6, 7, 7 and 8, 8. And as we are viewing from the front view, this portion only will be visible completely, but not this. So I will darken this portion complete. You can observe that this time it was very easy for me to draw this ellipse from the last time, because I have taken now more points. This half portion will be visible and this will not be visible, but it's there. That is why we are drawing this in the dashed lines. So this completes our figure, front view as well as the top view. And I need to dimension this figure. So I'll first dimension this circular portion, which is diameter 30 and the axis height as 65. Also, this angle is given, so this becomes very important to mark this angle 30 degrees.
This is the solution of your final solution of your fourth question. When the axis is inclined to vertical plane, you see this is the top view which is inclined.